Well, it finally happened. I finally ended up throwing somebody off the back of the bus for bringing up another example, trying to use it to justify there being a light delay between the sun and us, or the sun and the moon during a solar eclipse. Forget that. That's NASA not firing the lasers at the moon. This is where it's at now. This is exactly what I was talking about when I was saying you cannot use other things like GPS proves it, or LiDAR proves it. Light travels at 299,792 kilometers per second. No, it doesn't. But we go one further. Old matey that's telling me that during a solar eclipse, when the photons have hit my eyes, the delay has already happened. Huh? The delay of 8 minutes and 20 seconds has already happened. And the sun has already turned the 2.08 degrees. Like, it's just, it's, I don't know. You can see why he's off the bus, the back of the bus, out the window. In fact, I threw him out so fast, time slowed right down for him. Look, what is this about? I had the lasers set up already to do the bounce around the house, right? And then the same person that made that comment about the light delay has already happened by the time the photons reach your eyes. This was when I had the trouble with the seal that pushed me. Alexa, how do you say a seal pushed me yesterday in French?
A seal pushed me yesterday in French is un phoque m'a poussé hier.
God. And then I had that, and then from that I went straight on to setting the lasers up and having a cup of coffee, quite relaxed. And then the same guy who replied again. And this is where you've got to be careful, because this is where you could get sucked in with a one-on-one and end up smashing your bang against the keyboard and bang and throw people out the back of the bus. So, but I didn't do that. I'm turning it into a lesson of what they have people doing. He then said, what about the lasers that they fire at the moon? They prove 299,792 kilometers per second. Well, you can imagine my joy, can't you? You can imagine my joy. He's obviously listening, understands the subject matter. There is no lasers on the moon because they didn't go to the moon. But now, your man here is using that lie to defend the other lie about the speed of light. It's unbelievable. Now, what I will say to that chappie, it's a joy talking to people sometimes like this, when they bring up these perfect examples of a lesson. Now, during a solar eclipse, I presume he would have seen a solar eclipse. To be saying things like this so recklessly without having seen a solar eclipse would be unforgivable. Now, during solar eclipse, when, matey, you're in that sweet spot and you're looking directly at the moon, and behind that moon, directly behind that moon, precision, okay, is the sun. You'll see the sun's corona. And there are photons. You are stood. You're protected by photons. That light source launched at you 8 minutes and 20 seconds earlier. Why is the light source in the perfect position, almost as if it was radiating absolute light with no delay? Because that is exactly what it's doing. You're looking at the moon and you're protected by the moon, as the fiery ball called the sun radiates absolute light from behind the moon. You're protected. The moon is your friend, because when it moves out of the way, what happens? Boom! You have to close your eyes if you're looking at the sun. There is no delay, not 1.3 second delay between us and the moon, or an 8-minute and 20-second delay between us and the sun. It's obvious that it's absolute light. I cannot help you any further. I understand how confronting this must be, and I can see you're obviously trying to find some delay from somewhere, but there is no delay. But what you cannot do is use another lie to prop up that lie. And the other one is lasers on the moon. Now, I got curious, because I do. How do they do that? How far does Earth spin on its axis in 2.6 seconds? 1.3 for the light to get to the moon, another 1.3 back, 2.6. Well, I worked it out to be 1,200 meters, 1.2 kilometers. It's correct to within a few centimeters, right? Because I rounded up once. Basically, we've got the circumference of planet Earth. We also have 360 degrees in a circle. So I divided the circumference by 360 degrees. Now, there are 111 kilometers in 1 degree, right? Because if you divide that by that, we get 111. It's 111 kilometers. So that is 1 degree. If we then multiply that by 2.0, can you see that? If we multiply that by 2.08 degrees, we then get 230.88 kilometers. I took it to 231, right? So 2.08 degrees equals 231 kilometers, right? So in 8 minutes and 20 seconds, planet Earth spins anti-clockwise by 231 kilometers. Now, I then wanted to find out how far planet Earth spins on its axis in 2.6 seconds, because that's how long it takes for a light beam to hit the moon from here and then bounce back. So we know 8 minutes and 20 seconds is 500 seconds. So I divided the 231 kilometers by 500. We get 462 meters every second. We are spinning on our axis anti-clockwise 462 meters per second. We hear 24 hours, 1 whole revolution, but in 1 second, we spin 462 meters in a second. Doesn't feel like it. Probably another point for the flat earthers, maybe. 462 meters per second. That is what we are spinning on our axis. But are we? Anyway, that's irrelevant. So then I found out, I multiplied that by 2.6, 1,200 meters. So the laser, bang, leaves here to the moon, takes 1.3 seconds, and we spin on our axis 600 meters. Bang! The laser hits the moon, starts its trip back. By the time it's got the moon and come back, we have moved another 600 meters. So how would they do that? Look, I can't believe I'm even working it out, because there is no reflectors on the moon, okay? It's a common sense thing. It's understanding how unlikely it is that they successfully landed on the moon 6 times between 1969 and 1972. And in May 1969, Apollo 10 went up there and took photographs. They dropped to within 9 k's of the moon and slowed down to 2,300 miles an hour, I think. Neil, love those. And then they shot back up to the command capsule and came back. That was in May 1969. And then Neil and that went up and finished the job. Not. There is no logical answer for a solar eclipse with finite light. It does not work. You can either think for yourself or you cannot think for yourself. This is a crossroads. Yeah, but what about, see what I mean? What about the lasers? That proves, one proves the other. No, that's one lie propping another lie up. That's how these things work. They're deeply woven into the fabric of the matrix. These freaking lies, and they're so obvious, right? Solar eclipse. If you can understand what is happening during a solar eclipse, you'll know that every time a photon is brought up, it shouldn't have been brought up, because there is no such thing. All right, 10 minutes. I have the lasers set up around the house, but as you can see, I'm banging things with this stick. So I might have to unwind. Fancy using the lasers that they shoot at the moon as justification for some kind of light delay between the sun and the moon during a solar eclipse.